Here's an acceleration example. The acceleration is the change in velocity divided by the change in time, which of course means the final velocity right here minus, let's make an F, minus the initial velocity divided by the final time minus the initial time. So the unit-wise acceleration is meters per second squared. The velocity is meters per second, and the time is in seconds. Okay, so let's do an example similar to one of your homework problems. Let's say that a car goes from an initial velocity of 32 meters per second, and it does it in the final velocity is going to be, let's just to make it simple, 22 meters per second. So one of the things to notice is the final is smaller than the initial, and so when you look up here, you can tell that you're going to get a negative. You're going to get a negative acceleration. Alright, and let's say that the car does this at a constant acceleration. I'm just going to make this up. Let's say a constant acceleration of, I don't know, how about 2.3 meters per second. Meters per second squared. Okay, because those are the units of acceleration. So with that information and this equation, what the question would be is how much time does it take? How much time does it take a car initially traveling at 32 meters per second and accelerating at a rate of 2.3 meters per second squared, and of course it's going to be negative. I didn't really put the negative here, but you'll see that it's negative, where the final time, the final velocity is 22. All right. All right. Since I've already said that it's slowing down, and you can see that from the initial velocity being 32 meters per second and the final velocity being 22, we're going to go ahead and put the negative sign in right there. So there's a negative 2.3 meters per second. All right. So how do we solve this? Really, what we're looking for is the time, right? So that's the question: is how much time does it take a car to go from 32 to 22, accelerating at negative 2.3 meters per second? So what is the time? Oops, that's supposed to be a question mark. Sorry. All right, so and we're not interested in an initial time, so let's assume that the initial time is 0, so we can make that assumption. So t initial is 0, so we're really solving for the final time, or really just t. Anyhow, so if you look back at this equation, this is going to be t, in the denominator here. Here, let me rewrite it down here. So it's going to look like this. It's going to be the acceleration, which we know is going to be v final minus v initial divided by the time. You could still put a delta t there. You'd be solving for delta t, but we're just solving for t. Okay, it's the same thing in this case because the initial time is 0. So we have to bring the t and apply some algebra and solve it so that t equals something. Okay, so what I'm going to do is multiply this entire side of the equation by t, and then this side of the equation by t. And of course the t's cancel on this side. Alright, and let me rewrite this. This whole thing becomes the time times the acceleration is equal to v final minus v initial. And we got one more step to go. We have to isolate this and just solve for t. All right, and so we take this equation here, and we're just going to solve for t. So we're going to divide both sides by the acceleration, right? So acceleration, divide the whole thing by acceleration, and the accelerations cancel on this side, and then everything is in terms of just the time. So the time is equal to V final minus V initial divided by the acceleration. And all that we know. We have those values. We know that the final time was 22, the initial time was 10, so it's going to be 22, it's meters per second, minus 32 meters per second, divided by, what was the acceleration? Negative 2.3 meters per second squared. And now you can add meters per second to meters per second, or subtract them in this case, and so that's going to be 10 on the top, meters per second, and the meters will cancel, and one of the seconds will cancel, and it'll leave you with 1 over seconds, which of course is just seconds. Alright, so here, let me do that right here. So the time is equal to, so you can see 22 minus 32 is minus 10, so that's in terms of the numerical value, divided by minus 2.3. So in terms of that, and we have meters per second divided by meters per second squared. Let me concentrate. So notice the negatives cancel. So let's see, what's 10? What's 10 divided by 2.3? Oh, it's going to be 4.35, something like that. So 4.35, and this cancels this cancels one of these, and so you're ending up with 1 over seconds, which flips up to the numerator to give you seconds. So it's 4.35 or 4.4 seconds, depending on how you would round that. Alright, and that should do it.